Okay, we're going to look at number 3 in section 10.5, which wants us to apply the ratio test. So just a reminder, you'll have this summary of tests for series sheet that I give you. And the first column is the series, then the conditions for convergence, and then divergence, and then comments. And if we go down to the ratio test for this series, we know that it will be convergent if this limit is less than 1. We'll know it's absolutely convergent in that case. And if this limit is greater than 1, then we know the series diverges. Of course, if this limit is 1, then the test is inconclusive. And this problem just wants us only to use the ratio test to reach one of these three conclusions. So let's take a look at this problem, right? Here is the uh, series we're looking at. And notice this is n equal 1 to infinity pi to the n power over n factorial. Well, let's take a look at what it will look like here. If I take and look at a sub n plus 1, I just replace n with n plus 1. Divided by a sub n is same as multiplying by the reciprocal, 1 over a sub n, which is just the reciprocal of that. And then I'm taking the limit as n goes to infinity. All these expressions are positive, so I can get rid of the absolute value bar. And again, pi to the n plus 1, remember that's pi to the n times pi. And this pi to the n and this pi to the n will cancel, leaving 1 pi up top. And then n plus 1 factorial, remember I can write that as n plus 1 times what? 1 less than that, n times n minus 1 times n minus 2, etc., which is n factorial, right? So this n factorial and this n factorial, I can divide numerator and denominator by that. And all I'm left with on the bottom is n plus 1. And the absolute value of pi over n plus 1 is just pi over n plus 1. And what's the limit as n goes to infinity? Well, the form of this limit is pi, which is about 3.14, over infinity, right? In other words, we're dividing pi by a larger and larger value, and we know that limit's going to 0. Important thing is, since the limit is less than 1, we know that the series is absolutely convergent and therefore convergent by the ratio test. Okay, it's a quick one. Hope that makes sense, and this is the type of support I'll be looking for when you do these problems on the test.